Alright guys, I'm back. I'm going to see if I can do one more before my tablet runs out of batteries here, so I apologize if it cuts off midway. So I'm going to solve x minus 6 over 5x plus 1 as an absolute value greater than or equal to 0. Alright, so I'm going to take the argument and sandwich it, which really is quite silly. Of course, there's no negative 0, so this will just be a single-sided inequality. And I'm going to resist the urge to multiply by 5x plus 1 on each side to cancel out the denominator, because that would result in this, which would result in this, which is absolutely not even close to the right answer. So again, whenever you have an inequality symbol, you do not clear the fraction by multiplying through with the LCD. So what you have to do instead is set each, the numerator and the denominator, equal to 0 and solve so that you can find out the critical values. And we will get the critical values of x equals positive 6 and negative 1/5. And this one right here is actually not one that we can use in our final solution, but it is one that we can use to divide up our number line. All right, so we have negative 1/5 over here, and we know for sure we're not using that, so I'm going to put an open circle. And positive 6 over here, which we may be using. And since we have an equivalent statement, we'll say, yeah, it's a closed circle, but we'll test it just in case. So putting in 6 right here, if I plug 6 into my numerator, that becomes 0. Anything divided, or 0 divided by anything else, is still 0. The absolute value is 0. 0 is greater than or equal to 0, so of course 6 would work. So we know for sure that we are not including negative 1/5 because it would make my denominator 0. And we are including 6 because it would make the whole left-hand expression equal to 0, which is good. All right, so after we have figured that out, now we want to test values within each of the regions. So let me get my different color here. I'm going to test in this region, I'm going to test negative 1. In this region, I'm going to test 0, and in this region, I'm going to test 7. So I will just systematically plug each one of those into my original inequality and see if I get a left-hand side that is greater than or equal to 0. So I will first have the absolute value of 7 minus 6, which is 1, over 5 times 7, which is 35, plus 1, which is 36. So the absolute value of 1 over 36 is indeed greater than or equal to 0, so this side is good to go. Now I did forget to do one step that I've told you guys to do, so in order to be a good model, I'm going to go back before I move ahead any further and do the step where you rewrite your number line boundaries in interval notation with the critical values as the boundaries. I need more space here. So this one is from 6 including 6 up to positive infinity. In the middle here I have negative 1/5 not including it, up to 6 including it, and all the way to the left I have negative infinity up to negative 1/5 not including it. Alright, so what I have done is I figured out that this first one that I tested the one all the way on the right. This one is a good one. So we will be using that region of the number line as part of our solution set. I'll go do 0 now, so I'm going to plug 0 in here. So if I plug 0 into my original inequality, I will have negative 6 over 5 times 0 is 0, plus 1 is positive 1. Now the absolute value of negative 6 over 1 is actually 6, which is greater than or equal to 0. So that one's good too. You may be noticing by now that no matter what, we're going to have a greater than or equal to 0 result, because the absolute value means it's a distance, which is a positive, and positives are always greater than or equal to 0. In fact, by definition, a positive is greater than 0. It's another way to say positive. So this is all very trivial. We shouldn't even be going this far with it. Like, if we are clever enough, or if we're aware enough, we would notice this right away, that it's always greater than or equal to 0. So it's all real numbers is the answer, right? But I'm just going to continue going on, because if it wasn't one that is always true, it would be interesting. This is how you would approach it. Right, so we've tested 2 of the 3 regions. We're going to test that last one with -1. So I'm going to plug -1 into the inequality. So I would have -1 minus 6 is -7. 5 times -1 would be -5 plus 1. -5 plus 1 would be -4, which would give me positive 7/4. Absolute value is 7/4, which is indeed greater than or equal to 0. So they're all good, right? The only thing, though, is that this really is not cool. We can't use that. So even though before I did say always, so it would be all real numbers, actually, because we have a situation down here, we do have to restrict the domain and not allow x to be -1/5. So actually, this is not the final answer entirely. So let's go ahead and finish this off by writing the... So it's going to be from -infinity to -1/5, jump over that -1/5 and pick up on the other side and go towards positive infinity. So that is the final answer. And like I said, this one could have been answered fairly quickly if we had noticed that, well, clearly it's an absolute value, so by definition it will be greater than or equal to 0 always.